Today's lesson is 5.3, Medians and Altitudes of Triangles. The objective is to use properties of medians and altitudes of triangles. So you'll want to get some vocabulary down for this lesson. Our first vocabulary word is a median of a triangle. And the median of a triangle is just a segment whose endpoints are the vertex of the triangle and the midpoint of the opposite side. Now let's take a look at an example of that. So we have here triangle ABC, and so our vertices are A, B, and C. And the median of this triangle is segment AD. And that's because its endpoints begin at the vertex A and then go to the opposite side of A, the opposite side being BC. And when it goes to the opposite side, it splits BC directly in half. So you have two congruent segments, BD and DC. So BD is congruent to DC, and that's because AD is the median. So another vocabulary word is centroid. And the centroid of a triangle is just where the three medians of a triangle intersect. The book calls this concurrency, but it's just the point where those three medians intersect. So if you take a look at this triangle below, we've got three medians. We've got AE, we have CD, and BF are all medians of this triangle because they divide the opposite sides of the vertices into congruent segments. And the point where they intersect, let's call that point P, is the centroid. Now that leads us into Theorem 5.7, which is the theorem about concurrency of medians of a triangle. And what we learn in this theorem is that the segment formed by the centroid is exactly 2/3 of the median. So if we take a look at our example up there above, AP is 2/3 of AE. You know, because AP, P is the centroid, it forms that segment AP, and so it's 2/3 of segment AE. And also CP is 2/3 of CD. Now it's real important here on this that you're starting with your vertex. So notice that I'm always starting with my vertex. So BP is 2/3 of BF. Now why that is cool and why that matters is because you can actually balance an object if you find that centroid, that center point where you can balance and the weight will be distributed equally. So there's a thing in your book where you can try to fold a piece of paper and find that centroid, and if you then just take your pencil, you can balance it on that central point. And that centroid is 2/3 of the way, 2/3 of the distance of the entire median. Okay, a couple other vocabulary words that I want you to know. First of all is altitude of triangle. Altitudes are perpendicular segments from a vertex to the opposite side, or the line that contains the opposite side. So perpendicular is the key thing there. It forms a right angle with the opposite side of the triangle. Now the altitude is not necessarily the median. Could be, but it's not necessarily. And then I want you to know what orthocenter is. And orthocenter is where those three altitudes intersect. So just like we had centroid, which is where the three medians intersect, orthocenter is where the three altitudes of a triangle intersect. Now in an acute triangle, the orthocenter is going to be inside the triangle. In a right triangle, the orthocenter is on the triangle. And in an obtuse triangle, the orthocenter is outside the triangle. Now I'd like for you to look on page 281 of your book and see if you can figure out why that might be true. Why is the orthocenter inside the triangle in an acute, and on the triangle in a right triangle, and outside the triangle in an obtuse triangle? And send me a note on Edmodo and tell me why you think that is. Okay, we're going to look at some examples starting on page 282. We'll start with number 8. And we've got a triangle here, triangle DEF. And the information that's given to us is that P is the centroid of DEF and EH is perpendicular to DF. They also tell us that DH is equal to 9, DG is 7.5, and EP is 8. And I've labeled all that on the drawing. Question number 8 says to find the length of a FH. Well, I know that EH is the median of DF. And the reason I know that is because that P is the centroid that was given to us. So if P is the centroid, that means that those other three lines, where those other three lines intersect, those all have to be medians. And I know medians split the opposite side in half. So if DH is 9, that means FH also has to be 9. Now in question number 10, we're supposed to find the length of PH. Now remember, we know that our centroid is 2/3 of the way from the vertex it's 2/3 of the whole median. From the vertex to the centroid is 2/3 of the whole median. So I know that that segment EP is 2/3 of EH. And if I knew how much all of EH was, I could just subtract EH minus EP, and that would give me PH. That would give me what's left. So I know EP is 8, but what I don't know is what EH is. So I could put a variable in place of EH, and I'm just going to call that X, and then I could solve that equation. It's a simple equation to solve. Just divide both sides by 2/3. And you guys might know just in your head that 8 is 2/3 of 12. So the whole segment of EH is 12. This whole segment here is equal to 12. If the whole segment is 12 and this little part is 8, that means the other little part from P to H would have to be 4. So PH is equal to 4. Okay, now I'd like to look at example 2 on page 280. And the example 2 says find the coordinates of the centroid of triangle JKL. So I'm trying to find that point in the center where the three medians meet. So in order to do this, I'm really going to have to be able to find the median first. And I know, once I find the median, then I can probably find the centroid. So I'm going to find the median of side LJ, and so I want to find those coordinates of that median between L and J, and we'll call that point N. And I know that the median, remember, is halfway, exactly halfway between L and J. So halfway between 3 and 7 is 5, and halfway between 6 and 10 is 8. So the coordinates of the median of LJ, point N, is 5, 8. Now the next thing I want to do is to find the distance between K and N. Because that distance I know, the centroid is going to be 2/3 of that distance. So if I find the whole distance, then I can find the centroid distance as well. So the first thing I notice is that the X doesn't change between K and N. So really this distance is only the difference between the Y values, 8 minus 2. So the distance of Kn is 6. So Kn is 6 units. Well, remember that Kp is going to be 2/3. If I'm calling the centroid point P, then that means that Kp, let's just say it's here, and we're calling that point P. I know that KP is 2/3 of KN, and we know that KN is now 6. So KP is 2/3 of 6. So KP has to be 4 units. KP is 4 units. So that means, since it's on the same line as Kn, that means the x value doesn't change. But if I just add 4 to K, the y value, then that is going to be 5, 6. So the coordinates of the centroid are 5, 6. Okay, the last example that I want to do is number 40. Now this is really just an algebra review. This is not anything to do with this lesson. But we're going to be using writing equations later, so I want to make sure that everybody's up to speed on this. This is what algebra's been doing lately. The instructions here for number 40 say write an equation of the line that passes through point P and is parallel to the line with the given equation. So we want an equation that passes through this point, -3, 8, and is parallel to this other line, y equals -2x minus 3. Now, if you remember from algebra, what we know about parallel lines is that parallel lines have the same slope. And so we know that the slope of our equation is going to, of our line, is going to be -2, because the number in front of x when y is by itself is the slope. So we know that our slope, m, remember slope is used, the variable m is used, our slope is going to be -2. So what we know about our equation so far is the equation of our line is -2x, but I don't know the y-intercept. So we know so far that ours is -2x plus b. Now, if I just substitute this point, because I know that this point, -3, 8, lies on my line, if I substitute that point in for x and y, then I can figure out the y-intercept, and then I can write my equation. So I'm going to substitute -3 in place of x and -8 in place of y. So -2 times -3 is +6. And then I'm trying to figure out what number do I add to 6 to make it equal -8. Well, it would be -14, but if you didn't know that in your head, you could just subtract 6 from both sides, and so b is going to be -14. So the equation of our line that's parallel to the line they gave us is y equals -2x minus 14 or plus -14. Okay, that's all the examples. So your homework tonight, pages 282 to 284, numbers 3 through 7, numbers 9, 11, 17 through 23, and 39 and 41. Don't forget to answer that question on Edmodo, why are orthocenters different for different types of triangles? And to kind of help you with that, if you look on page 281, that might help you answer that question.